this computer. All right, so basically right now we're going to be working on finding probabilities of normal distributions. In section 5.1, we did the finding probabilities of the standard normal distribution, which was strictly the table. We worked on left, we worked on right, we worked in between, we worked on or, and we also did the one where if you had 3 decimal places, how to figure that out. Remember, if you can round to either 1.61 or 1.62, meaning let's say it's 1.611, obviously you pick 1.61. If it's 1.612, obviously you pick 1.62. If it's 1.619, obviously you're picking 162. However, if it's exactly in between 161 and 162, for instance, 1.615, that one we can't decide whether we're going to pick one or the other. So we average out both of the quantities and divide by 2. So that's basically what we covered last class. Now here it says, a survey was conducted to measure the height of U.S. men. Okay. In the survey, respondents were grouped by age. In the 20 to 29 age group, the heights were normally distributed with a mean of 69.6 and a standard deviation of 3.0. A study participant is randomly selected. Now, guys, quickly, why would you place why would you do it by age as well? What's important about doing the heights by age? Different generations. You want to compare heights from different generations to see if there's an upward trend or downward trend. Well, it depends. It depends. And last, I don't know, I remember thinking that, you know, like 50 years ago, are people taller on average than now? You know, so that person, I mean, I think as you get older, do you get slightly shorter because your back compresses or something like that?
Yeah.
But I mean, it might not be trivial though. So I'm gonna get shorter. So there. So let's begin. It says, okay, what's the mean they give us here? Okay, so what you do here, so let's say we're gonna start part A. We draw out a sketch of our normal distribution. Here is our mean. It says 69.6. I like on the side here, reminding myself what sigma is, it equals to 3. So that's about right. The average height is 5'10", with standard deviation of 3. That means I'm a little bit over 1 standard deviation away from the mean. Negatively, of course, not positively. But that doesn't mean anything. Remember, that's how the distribution exists, because if not, we would have a uniform distribution. And it's the beauty of life, the variances we have between people. Makes the world what the world is, and not be extremely boring, I guess. All right, and so now it says, find the probability that his height is less than 66 inches. Where would you locate 66 inches? On the left of 69.6 or on the right of 69.6? And so we're just sketching. I mean, I don't know if this is an accurate representation, but something around there. I don't know, whatever. So there's 66. Now I should zoom this out a little bit so you can see it. Oh. There we go. So that's our situation. And it says less than. If I'm going to shade less than, where should I shade? On the left. So far, so good. Pretty standard. But here's our problem. This is a normal distribution, not a standard normal distribution. So what should be our next step? A z-score. Correct. We're gonna convert an x value, a random variable, to a z-score. Remember, a z-score is just a measure of how many standard deviations a particular score is from the mean. That's all it is. Give me 1 second, because gotta get David. There we go. So let's begin. Now I'm gonna go. I like writing things over and over again. So we're gonna apply a z-score here, right? Our z-score. I'm gonna make a little arrow here. Our z-score is x minus mu divided by sigma. That's how it is. All right. Always the x. Now the x could be the middle where if our x is the middle. And if you did it in the middle, it'd be 0. Because let's say our x was 69.6. We do 69.6 minus 69.6 and we get 0. It's possible. I could say, what is the probability that the height of the man is less than 69.6? So in that case, you take x and subtract the mean, which is the same, and it comes out to 0, which makes sense because it'd be z equals to 0 in that case. But in this case, obviously it's going to be negative. So let me get the door again. Okay. Okay, give me 1 second. Let me get Emily's attendance. Hey, nobody talks about COVID anymore. Everything is Russian. Have you noticed that? What else do you expect? But I think my dad thinks Ukraine could win. I'm like, Poppy. I'm like, Poppy, come on. Maybe the insurrection could win over extended time, but I don't know about winning. All right, so here we go. 66 minus 69.6. That comes out to negative 3.6 divided by 3. And so we get a z-score. Now I should really compress this. Let me compress it because I want to have space here. So this comes out to negative 1.2. Okay, so that means this situation is depicted by the following. It's depicted by a standard normal distribution, or equivalent to a standard normal distribution with, and notice where I put the z-score there. See, these are z's, these are x's, right? Let me keep consistent, at the very least, keep consistent. Make it at least orange like the other one. So our z here is negative 1.2. And we're shading the same area. So this area here I'm shading is going to be equivalent to the area to the left of 60. That's all. That's all there is to it. So I'm going to grab my table. Now, what's the area for negative 1.2? 0.11. Yep, it's the area to the left. Remember, our tables always read to the left. Our table says that the area there, right here, is 0.1151. Therefore, this area here is 0.1151. Therefore, to answer this question, the probability of x being less than 66, the height of the man being less than 66, is equal to 0.1151. That's how you do the question. I'm going to go ahead and do part B and part C, and then talk about a situation that could arise where I can ask a slightly different question. And that's it. And then you guys get to work on your classwork. I'll put the answers on the board. If you have questions, you ask me. And we're almost done with this 9 weeks. We'll be done with the years very soon. Okay, so part B. Part B says, find a probability that his height is between 66 and 72. So I'm going to go ahead and draw the normal distribution again. And of course, we have a mean of 69.6. Same situation. And a sigma of 3. Now, they asked us here, and the way to do this, it says, the probability of X being between 72 but greater than 66. Okay, that's what they're asking. And the previous question was just as X is less than 66. In this case, it's between, and that's how we represent between. X is less than 72 and at the same time greater than 66. That's a between. Now, the first thing is, let's go ahead and locate 66. Obviously, 66 is somewhere over here, somewhere. Yes. Maybe I wrote it once and it didn't appear and I wrote it again. I don't know. How did that happen? But did I say it or did?
No, you said 69.
And I wrote 0.5.
Yeah.
I don't know what's happening. Maybe. All right, so 72 is somewhere over here. Now, we shade the area in between. So far, so good. Now, we want to find this area, but how many z-scores would I have to do in this case? So let's go ahead and do this. So we have 72 minus 69.6 divided by 2. That's one z-score, right? Then the other z-score by 3. Oh my gosh. Okay, and the other one's going to be 66 minus 69.6 divided by 3. So we have 72 minus 69.6 divided by 3.8. And the other one we just did in the previous problem, it was negative 1.2. Agreed? Okay, so now I like to write another curve. Some of you don't want to do the second curve. I don't know what's wrong with you guys. I love it.
Do we have to like it in that, but
Well, does it matter? No, but it's just great, a great habit. Good morning. So here we go. We have our curve. I'm going to go ahead and find our z-scores. One is negative 1.2. The other one is 0.8. Notice that when we do z, the middle is always going to be a z of 0. No need to worry about that, but just, remember locating your z's, how it goes. So here we go. We shade in the areas. You're welcome. Have a great day. So we know the area. Here's how we do between. We find the area for this one. We know it's 0.1151. And then we find the area for this one. Right? So 0.8. Just be careful. 0.7881. 0.7881. Now to compute this area in between, here, we're going to take 0.7881 and subtract 0.1151. Now, the result of that will indicate to you the area in between and therefore indicate to you the probability of being between 72 and 66. This comes out to 0.6730. So therefore, and you can't see what I'm writing. Therefore, the probability of X being between 72 but greater than 66 is equal to 0.6730. Make sense? Now, part C. Part C says, find a probability that is highest more than 72. So here it says probability that X is greater than 72. So I'll wait because some of you are writing still. Give it a second or so. We'll start doing the situation. It's very simple. We do the same thing. Yes. Not 1 minus the z-score. 1 minus the area of the z-score. Yes. The area to the left is Z squared. Yes.
Good morning, guys. Interruption. Teachers, at this time, please release all students scheduled to take the FSA ELA writing exam. A list of all testers will be known this morning. Please assist the students who do not know what they're testing. Good luck, guys.
All right, so I'm gonna scroll this up.
Another case.
Yeah. We take a dump? Yeah.
Yeah, they put like screws in there. Oh, they put, yeah, they put screws in the one here.
That's funny.
You can't like use the stock.
That's
The one over there at the gate, and sometimes like in the morning, they'll just lock it right. So I come out, and the gate's like locked.
funny, man. Somebody should have recorded that. Well, like not like from the outside, not inside. All right. So guys, if you did this here, it's 72 minus 69.6 divided by 3. You know it's going to be 0.8 because we just did it. Now, a lot of you don't want to redraw graphs, don't want to repeat calculations. I mean, it takes a second. So this depicts 0.8, something like around here. I mean, I'm exaggerating there, whatever. Well, I'm not really exaggerating there. I mean, I could do a better job. Let me do a better job. Let me just make it look like the other one. All right, somewhere over here, whatever. Remember, these are, look what I did over here. I didn't catch myself. These are X's. So what we want to do is find this area here. Right? What's the area to the left going to be? Well, we just did it, right? It was 0.7881. Now notice, why did I shade to the right? Because the probability of X was greater than, not big, because of this here. This inequality symbol here said greater than. Okay? So what's the area of the full curve going to be? It's 1. So in order to figure this out, you have to take 1, subtract the 0.7881, and that's how you get the area to the right. 1 minus 0.7881, that's 0.2119. So therefore, the probability of X being greater than 72 equals 0.2119. Now, some books like saying this. Some books will write, the probability of X is greater than 72 is equal to the probability of Z being greater than 0.8, which is equal to the probability 1 minus the probability of Z being less than 0.8. That's not equal to 0.8. And this is 1 minus 0.7881, which is 0.2119. But I'm not going to require you to do that. That's dumb. Okay? But you see it, right? Here you're justifying everything. Okay, now, how can they make this question a little bit more interesting? If we read the question initially, they didn't give us how many men were surveyed. But let's say I surveyed, let's say I surveyed 100 men from the ages of 20 through 29, I think it was, whatever. And then I ask you about how many of those men would you expect to have heights greater than 72 inches. Well, we know that the probability of X being greater than 72 is 0.219. And if you take 100, and multiply that by 0.2119, it comes out to 21.19. So you would say approximately 21 men will have heights greater than 72 inches. That's what you do. Now, if there were 123 men, it's 123 times 0.2119. And similarly, if I ask you how many of the men will be between the heights of part B, let's say, between 72 and 66. 66 is my height. 63% of the men will be between 66 and 72. 67.3. Now remember, we don't consider something unusually tall or unusually short unless it's 2 standard deviations away. Right? So in this case, if it's 59.6 plus 3 plus 3, the top height is 65 points. I wrote it wrong. Give me 1 second. 69.6 plus 6. The top height would be 75.6. So around 6'3.5". That's where the borderline of like, well, you're usually tall. Because what happens is there'll be 2.5% of the men taller than that. And if you do 69.6 minus 6, 63.6 is the borderline where we start saying that only 2.5% of the men will be shorter than that. So that's 63.6, about 5'3.5". Okay. So I think some of you got the sniffles too, right? Like, right? It's going around. Nobody got sniffles? Everybody's in this. Why don't you want to admit anything? Are you scared that you're gonna be sent home because of COVID testing or something like that?